In this video, I will be describing Multimedia Science's Terminal Velocity Lab. It's a great way to have your students run a lab using computer software. For many years, I had students run a lab to find a terminal velocity of equally sized spheres of different materials. It was an excellent hands-on lab for the students, which led to a good understanding of both the concepts of and finding of terminal velocity, and was one of my favorites. However, there were some difficulties associated with the setup, running, and results of this lab. The equipment setup was tedious and time-consuming, both for me and the students. The data was not always very accurate, leading to graphs that were difficult to analyze. And due to the setup time and other difficulties, it was difficult to predict the timing and when to schedule the computer lab for students to evaluate the data. That led to the creation of the Terminal Velocity Lab software. So let's start the lab. First of all, there's the description that the students can look at that shows what the equipment would look like if the students had actually run the lab as usual. You can see there's a start photo gate, which stays at the top. There's a stop photo gate, which gets moved up and down to change the distance that the ball falls from the top to the bottom photo gate. There's also a step-by-step explanation of exactly how to run the lab. So students, if they forget, the directions that you give them, can always check on the step-by-step directions, saving you answering questions. There are 4 different balls: aluminum, cork, styrofoam, and ping pong, and the students will click on each one to take the data. I tried to make this lab as real to life as possible, so students will have to left click on the ball and hold the mouse down and drag the ball up to the glass tube. You can see that they must center the ball over the tube, and they have to get it as close as possible. Oops, you can see that if they break the photo gate, which would start the timer before they drop the ball, it will not let them take data, and they will have to start over. Also, if the students start the ball too high, it will say that they need to start over. If they hit the tube with the ball, they will have to start over. And in the case of any of these errors, they will not be able to take data. Now, they set the ball up just right, and they also center the ball both ways. They will then get the time it took for the ball to go the given distance. Then they will reset, and they will change the distance. So essentially the data will be a distance versus time of the ball falling down the tube. There's also a center the ball automatically in case that students find it too difficult and get too frustrated. Then we'll go back, we'll do the cork ball, we'll run the same experiment, and we'll continue for all 4 of the balls. There are a number of documents that are included with the Terminal Velocity Lab software. One is a set of instructor's notes, which allows you to figure out exactly what you should do with your students in order to run the lab and simulation and installation instructions. There is a lab handout that you can give to your students, and this has a description of the equipment and a step-by-step procedure and analysis. Data tables, you can decide to give these out or not, have your students make their own data tables. A set of questions. They will have to make a graph of the final velocity versus time, and they'll also have to do a calculation or a set of calculations to get the distance time data into the final velocity of the balls as they fall down the tube. There is also an included answer key with all of the data and answers to the questions. When the students are done, they should have created a graph of velocity, final velocity versus time. As you can see, the heavy ball essentially falls with a slope near the acceleration of gravity, and the other balls, the ones that are less dense, will have a smaller terminal velocity. One of the interesting things is that since the students have to drop the ball a certain distance above the tube, exactly what that distance above the tube is means that there is some play in the data, so you will not get perfectly smooth curves. When I ran this with my students in the real world, they often would be so bad at dropping the ball near the top of the tube that you couldn't even see the curves at all. So that's one of the nice things about this lab, is that it forces students to get good data. Now it turns out the tube is exactly 4 meters tall, and one of the things that they're asked to do is to find the area under the curve of the velocity turn curve. That should give them the displacement, or in this case, the height of the tube. And you can see that it comes out very nicely and close to the 4 meters that it should. If you're interested in the Terminal Velocity Lab software by Multimedia Science, you can find it at Teachers Pay Teachers. Here is the URL. Type in the Terminal Velocity Lab software. It comes in both PC and Flash versions. So thank you for watching Multimedia Science. Have a good day.